Hi, in this video, we are going to look at inequalities. So before we get started with inequalities, let's just think about what an equality is. If you think about the most simplest of sums, where we are using an equal sign, we're writing an equation, then we all understand what is meant by that. It's telling us that if you add these two digits together, you get this digit. 5 plus 3 is 8. And the equal sign is confirming that both sides are of equal value. They are the same. And of course, we can do that also with algebra. So we might have something like 2x plus 10 equals 18. And hopefully you recognize that that is saying that this expression must be equal to this value. And then we know the rules of how we work with equations. Whatever we do to one side, we must do to the other to keep that equality. So if we wanted to solve this to find out what x was, then the first thing we'd do, we'd subtract 10 from both sides. So we would say 2x equals 18 minus 10, which is 8. We must subtract the 10 from both sides. And then because x is being multiplied by 2, we can divide by 2 to get x. But then, of course, we must also remember to divide the other side by 2, and we get 4. So therefore, we work out that x is 4. And we can always check this by substituting the value back in. So if x is 4, 4 times 2 is 8, 8 plus 10 is 18. Yes, that all looks good. So that's working with equations. And when we come to look at how we work with the inequalities, it's very much the same principle. But let's start by thinking about what they actually mean. So we've got 4 different symbols here. And let's just clear up exactly what they mean. If you look at the shape of this, it's got a small end this side and it looks like it's opening up. So this is telling us that x is greater than 5. X is greater than 5. So we don't know what x is. We know what it isn't. It isn't any value that is less than 5. But it can be any value that is greater than 5. Let's have a look at this next one. So this next one is slightly different because we've got this added line here, which represents equals. So this is telling us that x is equal to or greater than 5. In the first example, if we could, we'd have to recognize that x cannot be 5. It's got to be more than 5. It could be 5.00000001, but it must be greater than 5 itself. And in the second example, x can be equal to or greater than 5. Okay, so this symbol, we can see it's been switched the other way round. So logically thinking, that must mean x is less than 5. The small end is now pointing at the x, so we can say x is less than 5. And in the final example, we've got this added line again, so that is telling us that x is equal to or less than 5. And they are the symbols. So if you get confused, people often confuse these symbols. Just look at the shape of it and think, this must be greater because it's the opening side of that symbol. And this symbol looks very small at this side. Okay, let's move on. One of the things we can do is we can show these inequalities on a number line. And this is how we do it. So we don't know what x is equal to, but we do know that it's greater than 1. So we set our boundary at 1, and we do that by just drawing a circle. And we leave that circle empty to show that it's not included within the values. And then what we need to do is draw a line and put an arrow at the end of it to show that all of those values, x could be any one of those values and any other values above that. So the arrow is telling us that that's going to go on and on and on. Infinite number of results. So the only difference when we've got this symbol is that the number here is included, and to demonstrate that we draw a black circle. So we colour in our circle, a mauve circle in my case, and again it's saying x is equal to or greater than 2. So we set our boundary and then we draw our line, and we remember to put an arrow at the end of it to show that it could be any value above that. Okay, if you feel confident, pause the video, have a go at the next two. Right, so here we're looking the other way around. So x is less than 4. So we're going to set our boundary at 4, and we're going to do it as an unfilled circle because we're not including 4. And then our arrow is going to go all the way along here. I would recommend probably using a ruler to do this. And we need to put that arrow at the end to show x can be any value that is less than 4. And then finally, we've got x is less than or equal to 3. So this is where our boundary is. And it includes equal to, so we can fill that circle in. And then I'm going to draw a line. Whoops, wrong direction. Very easy to do that. In fact, when you're making your line, just double check it after you've drawn it that it is going in the right direction. So x is less than or equal to 3. So here's our boundary. X can't be any value over here, but it can be any value along that line and beyond. Okay, so that is drawing inequalities on a number line. Let's move on and see what's next. So just an added complexity here is where we've got x and we're told both sides of its boundary. So this statement here is telling us, well, why not pause the video and have a think about what that is telling us and start again when you're ready. So it's telling us that x is greater than -2, because we could look at that either way. We could say -2 is less than x, or we could think of it as x is greater than -2. X is on the larger side of the symbol, but it goes on to tell us that x is less than or equal to 4. So how are we going to draw that on our number line? Well, the first thing is, let's mark off at -2, and x is not included in that -2. So we're going to draw a circle there that's unfilled, and then we're going to think about where it's going to end. X can be equal to 4, but it must, or less than 4, must be less than 4 or equal to 4. So I'm going to put the other boundary here and fill it in because it's included. And then I'm going to draw a line connecting the two. Okay, so here we don't have the arrows because we've got defined boundaries for this x. X is greater than -2, but less than or equal to 4. So anywhere along that line that we've drawn, x could be equal to, but it cannot fall with outside of those boundaries. Okay, so that is number lines. So the next sort of question you might get is about solving inequalities. Well, if all you have to do here, if you can do algebraic equations, then you can solve inequalities because the rules are exactly the same. All we want to get it to is so that x, in this case, we've got the greater sign. So we want to find out what x is greater than. And we treat them exactly the same way we would equations. So we can say 3x minus 8 is greater than 16. So what we want to do is isolate the x. So let's start by saying, well, there's 8 being subtracted, so let's add 8 to both sides. And then we get 3x is greater than 16 plus 8, 24. Okay, and again, we want to isolate the x. So at the moment, it's being multiplied by 3, so we can divide by 3, but we must do it to both sides. So we divide by 3 and we end up with x is greater than 24 divided by 3, which is 8. And that's where we finish. So we still don't know the value of x, but we've simplified it to show that 8 must be greater than, x must be greater than 8. Okay, if you feel confident, have a go at the second one. Right, we've got 2x minus 1 is less than 9. So we want to get rid of this subtract 1, so we're going to add 1 to both sides. And then we get 2x is less than, add 1 to 9, we get 10. And then x is being multiplied by 2, so we need to divide by 2. So we get x is less than 10 divided by 2, which is 5. And again, that's us finished with that. So the inequality is x is less than 5. Okay, let's just do this final one. Here we've got 3y minus 4 is greater than 17. So therefore, let's add 4. And we get 3y is greater than 21. Y is being multiplied by 3, so we want to divide by 3. And we get y is greater than 21 divided by 3, which is 7. And so dealing with inequalities, when we've got to solve them, very straightforward if you know how to do equations. Exactly the same principles. Okay, so we're just going to look at some other problems involving inequalities. And this is another sort of typical question that you might get asked. It tells us n is an integer, so we know that n is a whole number. And then we're given this inequality, so let's make sure we understand what it's telling us. It's telling us that n is greater than minus 2. Okay, you could look at it as minus 2 is less than n, but absolutely the same to say n is greater than minus 2. And then we can go on to say n is equal to or less than 3. List the possible values of n. So the first thing we should ask is, could n be minus 2? And no, it couldn't, because we're told n is greater than minus 2. So the first integer that it could be is minus 1. Okay, and then we know that it goes up to and includes 3. So we can go on to say n could be 0, n could be 1, n could be 2, and n could be 3. And they are all the possible values of n. It must be greater than minus 2. Well, all of these are. And they are all integers. and it must be equal to or less than 3. And again, all of these fit that description. So that's our answer. Pause the video and have a go at the next one if you can. Okay, so here we're told n is an integer, and we are told n is greater than -4 or equal to. So -4 is less than or equal to n, or inversely, n is greater than or equal to -4. So n is an integer, write down all possible values of n. N could be -4, it could be equal to -4. And then let's look at the boundary the other side. It's telling us that n is less than 1. In that case, it could be -3, -2, -1, or 0. That's all of the numbers, integers, that fit between those two boundaries. It includes -4. It does not include 1.